So in this particular question, we need to determine the limiting value of the given rational function when x approaches infinity. So when we do a direct substitution, so we get infinity over infinity, which is an indeterminate form. Also, we see that the highest power of x in both the numerator and the denominator is 2. So that means we will have to divide the numerator and the denominator by the highest power of x. So that means we are going to divide each of the term by x squared. So the first term will be simply a. The second term will be bx over x squared. So that will give us b over x plus c over x squared divided by, now dividing each of the terms in the denominator by x squared. So the first term will be d, the x squared get cancelled. We have ex over x squared, so that will give us e over x plus f over x squared. Now we're going to substitute the value of x, so that will be a plus b divided by an extremely large number plus c divided by an extremely large number, infinity, which will be, again, in the denominator we have d plus e divided by infinity plus f divided by an extremely large number, which is infinity. So that means we have a b, which is when divided by an extremely large number is going to give us 0. So c divided by infinity is going to give us 0 as well. So we have d plus 0 plus 0. So that means the limiting value of this given rational function is going to be a over d when x approaches an extremely larger number. So we have to determine the limiting value of the given function when x approaches a very large number, which is infinity. So clearly when we substitute for the value of x, we are going to an indeterminate form, which is infinity over infinity. Now the next thing that we have to do, we'll look for the highest power of x in both the numerator and the denominator. So in the numerator, the highest power of x is 1, whereas in the denominator we have a highest power of x, which is 2, but we also have a square root there. So that means the highest power of x in the denominator is 1 as well. So what we're going to do, we're going to divide both numerator and the denominator by x. So we have limit x going to infinity. So we have the first term of the numerator, which when divided by x is going to give us 5 minus 6 divided by x. Now we have square root of 4x squared plus 9 whole divided by x. Now what we're going to do, we're going to take this x and put it inside the square root. So that will become limit x approaches 9 infinity 5 minus 6 over x divided by the square root of 4x squared plus 9 divided by, so x when it enters the square root will be x squared. So now we can further do a reduction. So that will become limit x approaches infinity. So we have 5 minus 6 over x in the numerator divided by square root of, so 4x squared over x squared will give us 4 plus 9 over x squared. Now we're going to substitute the value of x. So we have 5. So 6 divided by infinity is going to be 0. So we're left with only 5 in the numerator. Similarly in the denominator, we have 4 plus 9 over infinity. So that second term will be 0. So that leaves us with 4. And finally we have 5 divided by square root of 4, which is 2. So this is going to be the limiting value of the given function when x approaches a very large number. So in this particular question, when we substitute for the value of x into a given function, we are getting a form infinity minus infinity. So this is going to be an indeterminate form. So that means we need to convert a given function, which is f of x, into a form g of x over h of x. So that means we are going to do it by rationalizing the term in the numerator, which is root x plus c minus square root of x. So let's do that. So in order to do that, we are going to multiply the numerator by the conjugate of root x plus c minus root x. So that is going to be square root of x plus c plus the square root of x. Now we also have to do it to the multiply it to the denominator as well. So as the given function is the dimension of the given function does not vary. Now what we are going to do, we are going to multiply the terms, or these two particular terms, because they are having the form of a minus b times a plus b, which translates to a squared minus b squared. So let us do that. So we have root x in the numerator. Now we have square root of x plus c whole squared minus the square root of x squared divided by square root of x plus c plus the square root of x. So we get limit x approaching infinity, we have square root of x multiplied to x plus c minus x divided by square root. So what we're going to do, we're going to take square root of x as the common factor. So that is going to leave us with square root of x plus c over square root of x plus 1. So we have, this is done so that we can cancel out square root of x from both the numerator and the denominator, and that leaves us with limit x going to infinity. So also the positive x and the negative x will cancel out, so we have c in the numerator divided by 1 plus, now what we're going to do, we're going to combine the two square roots present in the first term. So that will be simply x plus c over x, which can be further reduced to x going to infinity. We have c plus 1 plus square root of 1 plus c over x. Now when we do the final substitution, that gives us c over 1 plus square root of 1 plus c over infinity is going to be 0. So it's simply going to be 1. So we have square root of 1, which is 1. The 1 plus 1 is 2. So this is going to be the final limiting value of the given function when x approaches a very, very large number. So here we need to determine the limiting value of the given function when x approaches a very large number. Clearly, when we substitute for the value of x with infinity, so we are getting the form infinity minus infinity. So we don't need this particular answer. So what we're going to do, we are going to look for the highest power of x in both the numerator and the denominator. So we have the highest power of x in the denominator is 1. However, in the numerator we have x squared, but then again we have a square root, so that means the highest power of x in both the numerator and the denominator is simply 1. So that means we have to divide both numerator and the denominator by x. Anyways, I'm going to perform another way. So what we're going to do here is we are going to take x squared as the common factor inside the square root of the first term. So that leaves us with 3 minus 1 over x squared minus square root of, so we're going to take x squared as the common factor in the second term as well. So that is going to leave us with 2 minus 1 over x squared divided by taking x as the common factor. So we have 4 plus 3 over x. This will be equals to limit x going to infinity. So we can pull out the x squared from the inside of the square root because x squared is a perfect square. So that leaves us with x times the square root of 3 minus 1 over x squared minus the square root of x. Similarly, we can pull out the x, leaving us with 2 minus 1 over x squared divided by x times 4 plus 3 over x. Now we see that x is a common factor, so we can cancel out x from both the numerator and the denominator, and that is going to leave us with limit x approaches infinity. So we have in the numerator 3 minus 1 over x squared minus 2 minus 1 over x squared divided by 4 plus 3 over x. Now we're going to substitute the value of x. So we have 3 minus, so 1 over, or infinity squared will give us 0, minus the square root of 2 minus 1 over infinity squared, again is going to give us 0, divided by 4 plus simply 3 divided by infinity, which is 0. So that leaves us with square root of 3 minus square root of 2 divided by 4. So this is going to be the limiting value of the given function when x approaches an extremely large number. So here we have to determine the limiting value of the given rational function when x approaches infinity. So we begin by first rewriting the given functions. So we take x as the common factor from the first term, which is 3x minus 1. So we have x multiplied to 3 minus 1 over x. Similarly, we're going to take out x as the common factor from 4x minus 2, and that will leave us with 4 minus 2 over x, all divided by, taking x as the common factor, will be left with 1 plus 8 over x times x multiplied to 1 minus 1 over x. Now what we can do, we can cancel out the common term, which is x, from both the numerator and the denominator, and that leaves us with limit x going to infinity 3 minus 1 over x multiplied to 4 minus 2 over x divided by 1 plus 8 over x times 1 minus 1 over x. Now we're going to substitute the value of x. So that is going to leave us with 3 minus 0 times 4 minus 0 divided by 1 plus 0 times 1 minus 0. So we have 3 times 4, which is 12, and 1 times 1 in the denominator, so that's simply 1. So this gives us the limiting value when x approaches an extremely large value. So here we have to find the limiting value of the given rational function. So we begin by looking for the highest power of x in both the numerator and the denominator. So that is 3. So that means we have to divide both numerator and then the denominator by x cubed. And dividing each of the terms by x cubed, so the first term will be 3 minus the second term will become 4 over x, plus this third term will be 6 over x squared, and the fourth term will be 1 over x cubed. Similarly, we divide each term by x cubed in the denominator. So we have 2 plus 1 over x minus 5 over x squared plus 7 over x cubed. Now substituting for the value of x, we have 3 minus 0 plus 6 over infinity, which is 0 minus 0. So the second, third and fourth term will be 0 in the denominator as well. So we have 2 plus 0 minus 0 plus 0. So that leaves us with a limiting value of 3 over 2 when x approaches infinity. So we have to find out the limiting value of the given function when x approaches infinity. So let us begin by factoring out the highest factor, the highest power of x from the numerator, so that is x cubed. So we factor out x cubed, that leaves us with 5 minus 6 over x cubed divided by, now we are inside the square root, so inside the square root we see that the highest power of x is 6, so we're going to take x raised to the power of 6 as the common factor. That leaves us with 9 over x raised to the power of 6 plus 4, which is equals to limit x approaching infinity. We have x cubed multiplied to 5 minus 6 over x cubed divided by, so the x raised to the power of 6 is a perfect square, so we can take it out of the square root, and that will leave us with x cubed multiplied by square root of 4 plus 9 over x raised to the power of 6. Now we can cancel out x cubed from both the numerator and the denominator, and we have finally the function 5 minus 6 over x cubed divided by square root of 4 plus 9 over x raised to the power of 6. Substituting the value of x, we have 5 minus 6 over infinity cube. Let's write it down. So infinity cube will be simply infinity divided by the square root of 4 plus 9 raised to the power of infinity to the power of 6. 9 divided by infinity power of 6, which will be infinity only. So that gives us 5 minus 0 divided by square root of 4 plus 0. So here we have 5 divided by square root of 4, which is simply 2. So this is going to be the limiting value.